All right, and we're live. What's up? How's it going? I'm Jared, and I'm gonna be leading you through the final project for fluids, or at least ours. It's a wind tunnel project. If you know, you know. So let's get started here. We're gonna be using fluid flow fluent. I'll name it wind tunnel video. Let's do it. Let's do it. Come on. We're gonna right click on geometry and open the design modeler geometry. That's the software we're gonna be using for this. Give it a second. How's your day going? Mine's great. Almost done with this, so just kidding. This is awesome. Okay, enough joking. Let's get started. So I just clicked the z-axis, so it aligned with the x and y axis. Now I'm going to the xy plane. That highlights it. Then you click this right here to start your sketch. I've tried it a few different ways. This way is the best, so just follow as I'm doing, and you should be all right. Let's start with our first sketch. Go into the line tool and doing 3 lines that are connected on the x-axis, just like that. Cool. Now we're dimensioning them out. Go here to this tab, go to horizontal dimensions, and click edge to edge, just like that, edge point to edge point. Just like that. You get your 3 values for here. We're, leaving our units in meters because that's what the assignment was asking for, which is fine by me. 1176 for the first one. This is just, given values of the wind tunnel. We'll put it all together in a second. I'll show you. 1.2192, and then 1.5748. Okay. Got my 3 values right here. And now we're doing another line over all 3 lines. This connects all 3 of them, just with another one. And with this line, we're going to be using it for a constraint. So under this tab, we're going to click midpoint, and we try and find how to highlight. Let's try and highlight the big one somehow. I had it for a second. There it goes. Here and here. Okay, now it's centered. That took a second, but you just find out how to click that line and then just click the other line, and they should automatically match up. Now, going back to drawing, giving ourselves 4 lines, just like that. Dimensioning these out, of course, from ending to ending. Cool. And these are also given values of the wind tunnel. So, the first region is 1.6256. 6256. Then the test chamber has a diameter of 0.6096. And we're going to copy that over to the next one too, because that's, a constant diameter for the test section. And then the last is 0.889. Okay. Now, we take these lines, as we did before, and attach them with our constraint. And we're going to be going back to midpoint. Click. one line, the line furthest to the left goes to the furthest left point right here. And it should match up like that. Boom. Looks good. Now, let's go through and connect the dots. Been doing this my whole life. I know how to connect the dots. There's 1, 2, and 3. 2 for the bottom 2. 1, 2, and 3. Okay. Now that you have this, you can start to select some of these lines here that you don't want anymore. Oh, I clicked an accidental line. Select this and delete. Delete. You don't need these lines in the middle anymore. Who needs them? All we need are the boundary lines. And I think that's good. So now we can close out real quick. Or actually, let's just minimize it. Let's go here, and we're just gonna duplicate this. And we'll go back to that later. Cool. Now we can finish it up. Let's go to concept and create surface from sketch by using our box select. Here we apply and generate. All closed up. That means our geometry is correct and all the lines are connected. So we're good to go. Let's close out a design modeler and start our mesh. Where's workbench at? Okay, cool. Go here and mesh, double click. Let's get her open. Mesh for this isn't too bad. It was a lot more complicated for the second project, so this takes a second to open. I just bought a new PlayStation, but it's not a new PlayStation, it's a used PlayStation. I played Fortnite on it. The OG map came out, but then it just went away. The new season came out. It's annoying. But anyways, back to fluid mechanics. Let's go. Never mind, it's still loading. Fortnite. Yeah, I'm not great. I'm not good at video games, but it's fun. Play with the boys. Okay. This is all open up now. Cool. Okay. Let's get started on our mesh. So first thing I want to do is select the edge tool. This is just, making sure that what you select is what you mean new. So I'm going to select all 6 of these edges using, control click. Hold down control and click and go down to create name section. And we're going to call this the wall. Sure. We're going to click off, left click, right click, name this the inlet. And the outlet. Cool. That's all good. You can check them here. What's what? And Now let's go to mesh. We're going to method. And for geometry, we are going to click this and apply. And for method, we're going to switch it to triangular. Cool. Generate. And if I back out of this, looks like that. Let's go back into the mesh though. We're going to go into sizing and go to select this for our geometry. And our size is going to be 0.01 meters. And this is going to give us a bunch of cells for our mesh. Let's go ahead and generate. This might take a second. It's the first night of Hanukkah tonight, or it's the second night of Hanukkah tonight. It's the first day of Hanukkah. Happy Hanukkah, guys. Did this load? Did you load? Tell me you loaded. I can't click out of this mesh. I think it's still loading. There it goes. This looks dark, but when you zoom in, there's a bunch of cells here, so we're good. That's gonna be our mesh. I believe so. And we're gonna close our mesh. So that's all good. Go back here and just like update it. Make sure it's all good. How are you liking this project so far? I thought this one wasn't too bad. It was like probably the hardest one, but once you get better at it, it gets easier. At least I think so. My computer's being slow. Ozbay kept saying to do this in the atrium, but that's not the move. Like, I'm so sorry if you guys have to do this in the atrium because this is not something I would want to do in public. It takes too long. Be like raging at the computer in front of everyone. Everyone's just like looking at me weird. Couldn't be me. Okay, I think it's okay. Mesh is updated. Let's go into setup. And we're going to be doing double precision with 2 solver processes. We're going to start her up. And I'll show you how to get all this set up running eventually. It's a little slow. But yeah, you're in Ozbay's class, and this is the final project. If you haven't taken the final yet, good luck on that. It was a tough one. I already took it, but you knew it was going to be hard. You already knew that. Like, it's not a surprise. Okay, everything's still loading up. Once the surface body loads in with the mesh, then we know we're good to go. Okay, cool. Give it one more second. let's get started with all of this stuff. So first of all, I want to turn energy on. And for our viscous effects, I'll show you what to do. We're going to change the K epsilon, standard, enhanced wall treatment, and pressure gradient effects on. Click OK. And let's go down to materials. Make sure our airs are fluid. Those are all good density and viscosity, just double checking, of course. And our boundary conditions, this is what we're going to check. Our inlet, this is what we got to input here. And this is just given in the project description. For us, we had 2 velocities. I'm going to choose one just for the sake of the video as 10 meters per second. Going to apply and close. And our walls here, all good. Wait, our walls, we should check if they're no slipping or not. Are they slipping or nah? They shouldn't be. You know that. No slip, stationary, just how I like them. And what's next? Let's go to reference values. And change enthalpy to 27,000. And we're going to be inputting from the inlet, right? Yeah. And our reference zone is the surface body. Don't forget to put those. Those are important. Now, we're going to double check our methods. These were already set from past projects, but just in case you don't have them, make sure that your methods look like this. Coupled, all these, just pause and go through them. You should already have them, but if not, then there you go. Okay, time to initialize. Click it up. And let's run the calculations. I'm gonna do 750 iterations. Calculate. Going home to see my family after this. I'm so excited. It's gonna be a good time. Got a big race this weekend. It's taking a while. And our calculation is complete. How does it feel? Feel good? Now let's check some results about it. So, first step. Let's go to graphics and contours. Double click on it. Open up this little window right here. And let's start doing our contours. We got 4 of them for this project. Yours could be different, so double check. But for us, We're going to start with a pressure contour. And it's just going to be static pressure. And we're going to select all and save and display. That's what it looks like for me. Close. Next one is a velocity contour. And make sure you're clicking those settings just as I am. Close. Next one's going to be similar, but this one's going to be total pressure. Yeah. Go back to pressure. Instead of static pressure, it's just the setting for total pressure. Very easy. That's what mine looks like. And last one is going to be dynamic pressure contour. Pressure is good. Total pressure and dynamic pressure. Cool. Select all as always. And that's what you're looking like. Close. Now we have all these. Can minimize them. Minimize graphics too. Why not? And go into plots. Time for XY plot. This is the tool we're going to be using to graph from the center line and the vertical distribution too. We're doing two different kind of sets of plots here. So we have a center line that we're going to be making. I'll show you how to make it. Go to new surface, go into line/rake. We're going to center line 1. We'll just call it center line 1. And our X dimensions are going to be -1.9558. 1.958. Just enter this in. Don't worry about it. It's right. I tried it already. Create and close. So that's there. And for our centerline plots, we're doing pressure, velocity, total pressure, and dynamic pressure again. So center line pressure and position on x-axis is good. If you're importing it into Excel, you would want to order points, but I'm just doing the video. I'm not really worrying about it. Do static pressure, direction vector. Let's do center line 1 and save and plot. That's what mine looks like. We're going to close. Let's do another one. So next one is going to be center line velocity plot. Velocity, magnitude, center line 1, save and plot that. Cool. Next one. It's going to be our total pressure. Center line, total pressure. Always clicking center line 1 only because that's like the only region that we're calculating at. There's mine. Close. And one more. Going to dynamic pressure. So center line, dynamic pressure. And these are all plots. They're all going to be labeled in the plot column. Boom. Okay. Now we are going to be creating our second set of XY plots with a different reference line that we're going to be creating. I'll show you how to do that one too. It's the same process as creating the first center line, but this one's going to be a vertical center line, so it's a tiny bit different. I'll show you. It's the same thing. New surface line. We're going to just call this vertical line, and we're going to be updating the y values. Since it's a vertical line, don't mess with the x ones. So this one is going to be 0.3048 to negative 0.3048. Create. Cool. Close. And first one, we're doing velocity. So for vertical, we're only doing 3. Velocity, dynamic pressure, and total pressure. I'm just not going to worry about static. So for this, we gotta switch it to position on y-axis. And if you were, going to order the points, then you would click that checklist, but I'm not going to. And we're switching plot direction from 1, 0 to 0, 1. Our y-axis is the direction vector, and we got this as, we're going to do velocity first, so let's do velocity. Vertical velocity. And vertical line. Let's try that. Boom. So it makes sense, like walls of the test section. Makes sense to me. And let's close. Open up another one. Let's do our velocity. Let's do our dynamic pressure now. Vertical dynamic pressure. And same thing. We're gonna have to re-click the y-axis constraints again, just like before. Dynamic pressure and vertical line. So double check. Boom, 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 boom. Try that. There's a little bit different graph, but still looks to be accurate. And our last one that we're going to be doing vertically is the vertical total pressure. Of the vertical line. Plot that out. Looks to be like a combination of both of them. Pretty similar to the other pressure line that we had. Close that out. Now let's get our let's just do real quick. I'll show you like how to look at like the streamline vectors. I'll show you real quick. Because for our project, we had to look at these. And results, graphics, vectors. Just like to look at the streamlines. Vectors of velocity, let's check it out, see what it looks like. Want to zoom in, you can see like, here, I'll zoom this way too. This is your free stream coming in. This was 10. And then, if you right click this, let's just change this to float. So it's just decimal places. So see, this is dark blue. So it means it's, velocity of 10, which is what it came in as. But as it enters the test section, it races to a green velocity. So somewhere between, 20 to 30. Looks about right. So that's what the velocity contours are looking like, the streamlines. And at the end, you can see that they are recovering The pressure and the velocity are recovering after going into the test section. That's what you want to see. Okay. Cool, guys. Now, I think that's it for the first part. We just did the regular wind tunnel. Now, we're closing fluent. Sure. Closing fluent and adding in our, body that's going to be in the test section, which for us is a circle. It's supposed to be a cylinder, but I'll show you how to add it. If you're doing a circle, then it's only a few things to add. Just got to give it a sec. Zoom out a little bit. There it is. I'll just click XY plane. There it goes. Okay, so here we are. Now it's time to add our cylinder, our circle. Let's go in, sketch. Let's make our circle. We're just gonna put it in the middle of the test section, just like that, because that's where you want to put something in a wind tunnel, just right in the center. And I did a few calculations off camera of how big the circle can be to avoid blockage effects. It's a little equation that the blockage ratio has to be, 7.5% or less for like all the effects of the walls to be avoided. So the frontal cross-sectional area of the test section over the, the actual diameter of the circle. So doing all those calculations out, we got that the diameter for our circle is 0.045. So here we go. I can dimension this out. 0.04572. And that was just, the diameter of the test section was like 0.06 or something, or 0.6. And then you just divide, or you just multiply by the 7.5% to get the diameter of this. So this should all be good. And now, just to make it even, I want to put it in the middle of the test section, just to make sure it's even. And that requires a little bit of math too. But, you just take this test section and divide it by 2, and then that's what you're going to be using. So use a horizontal measurement, this to that. And that measurement is going to be 0.6096, if it would go. 0.6096. Cool. Should be good. And now we're going to be creating our surface body, just as usual. So concept, surface from sketch. Let's zoom out and box select. Going to apply the geometry and generate. And we don't want the body to be included in the surface sketch, so that's what we want. We can close out of this. We're all set. And open up the new mesh, because we have to redo it, because it's new stuff in it. I'm enjoying spending this time with you. Nice and quiet, very peaceful. Just got done with my finals, so we're feeling good. Big weight off my shoulders. Get the next month to myself. Very nice. Okay. So just as last time, let's just name all of our edges using our edge tool. So I control clicked. Now I just right click on one of them, create name section, walls. Right click, left click, or left click, right click, I mean. Inlet, right click, or left click, right click. Outlet, and left click, right click. Just say cylinder. Is that how you spell cylinder? I think so. Okay. Let's start the mesh again. Click mesh. Now let's go to method, and we're just going to start off the same as we did last time. Click this, apply that. Triangles, you know the drill. Generate it. Pretty simple. Shouldn't be having too many issues with this. If you are, then just rewatch it enough times, you'll get it, I promise. Sizing, I'm gonna go here, apply that same surface sketch, and just as before, 0.01 for the sizing. So our meshing should be pretty similar to this one than like the last one, just so we can compare them both. You don't want to be doing too much different stuff with this. And, using that sizing creates so many different cells that, like, I really don't know if you need anything else, but once this is done, I'll add one more little thing. If you like, if you're really feeling like you want to be super accurate around the cylinder, then it's what I did. I don't see why not. It's not going to make your calculations worse to add something else in, so it's just an issue of the computer running it. Like my computer's being super slow right now. Okay. Now we're just going to do a little inflation. So we're going to start with this. Then the boundary is this. And I'm going to do just 4 layers. Yeah, that should work. Taking a little bit of time. Okay. This finished. Take a look. Boom. And, just that was the inflation right there. You see it. Okay. Just because there's a body in there, I felt like it was a little bit better to add that in. Now, I think we're done with this. And close out a meshing and update it. Just the same thing over again, pretty much. If you did the first one, this one shouldn't be too big of a leap. It's just a little extra step with the circle in it. All right, let's edit the setup now. Same thing, double precision, 2 solver processes. Okay, setup's all good. Let's go through and redo it. Models, energy on. Let's go to our viscous forces and edit that a little bit to capsulon, standard, enhanced pressure gradient effects on. Good. And material is going to be air, and our boundary conditions is what we want to change. Velocity of 10, just like before. More walls. We got a cylinder and the walls this time. Got 2 walls, technically. But let's just double check this. That it's a stationary and no slip. Just how I like them. And let's go to reference values and set that up. Since we're computing from the inlet, changing our enthalpy values and our reference zone. Now our methods should be the same, but let's double check. Yeah, looks good to me. Initialize. And let's run it. 750. Cool. We done. All right. For this one, it's not quite the same. We only have to do a couple contours in the graphics tab. Just pressure and velocity, I think just static pressure. Just using the everything. That's what mine looks like. Close. And do velocity contour too. Using these bodies. Check it out. Looks right. Fair enough. And now just finding your drag and lift coefficients. Pretty simple. These might not be accurate, you might have to do a little bit of math on your own, but I'm just gonna do the regular report definitions, just the regular coefficients. Not a big deal for me. Let's do force report, drag force, drag coefficient on the cylinder, and compute. 0.17. And let's try a little lift coefficient on the cylinder. Report def 1, I'm not even naming it. Compute that. I got a negative value. Doesn't really make sense, but you could always just go back and do a force report, lift force on the cylinder, and then find that out somehow too. But this should be everything you need to get this project done. You're gonna need to plot some things in Excel too. At least that's what we had to do, but I can't really show you that in this video. It's just a Fluent video. But hope you guys have a nice day. Thank you for watching, and good luck.